Hi guys, welcome inside the channel Sharing with People. Today we will continue our journey inside N8N, which is tool to automate or also play with AI, but N8N is more about general automation and AI is there just as an addition. But even though you can do many amazing things with it. If you remember, during our last video we were describing the basic flow of the AI music shorts or video generator. So it was something like that. So if I just make it bigger, you can see there is a lot of blocks which we will go over video by video. But today, before we jump into the description, I also want to show you the story generator, which is enhanced version of the music generator, and the idea is that they are using similar blocks where it's possible, because when you start building these things, then you quickly realize that to build just one can take a tremendous amount of time. And then it's somehow necessary to be able to reuse the blocks so that you can after that speed up building of anything else. And that's exactly what I did with this story generator, because the story generator is based on the experience that I gained during the music shorts or music video generator work, and then I just improved it so that it can generate also stories. In this video we will again just quickly describe what is it doing, and then later we will start going over the ecosystem which is necessary to build around N8N and so on. So now, before we jump into the description of the flow, let's describe the machine that we use to run it. And let me make it bigger, so hopefully we can zoom in. Let's see, cool. Now we zoom in. So in case of CPU, we have Ryzen 9950X, which means 16 cores CPU, which is able to run up to 32 threads, thanks to hyperthreading or simply technology of AMD, which is allowing you to run more on a single physical core, but in reality it's 16 core CPU. Then in case of memory, we have here two modules of 96 GB together. In case of memory, it's super important to know that usually the consumer grade CPUs, they have just 2 channels driver. So if you want to run your memory as fast as possible, then usually you can only use 2 slots. So in my case it's 2 times 48 gigs, and thanks to that I was able to overclock it into 6600 operations per second. Obviously these days we can buy even faster memories, and it's definitely visible. When you are playing with AI, loading huge models, it's definitely better to have faster clock speed of RAM. Then in case of disks, you have to ideally use fast SSDs. So in my case I have 2 terabyte SSDs which are connected over PCI Express 3. Please keep in mind that your CPU, even in case of Ryzen 9950X, it has 20 plus 4 PCI Express lines. So this means that there are some used for your GPU, and then there are some used for your hard disk drive. So when you run something simultaneously, usually it's a good idea to, for example, use just 2 SSD disks at the same time, so that you are not really limiting your bandwidth. Because in case of consumer grade CPUs, you have a limited amount of PCI Express lines which are connected into the CPU, and the majority of that is used by the GPU. Then you have this 4 extra. So to precisely describe it, in case of Ryzen, it's 20 which is reserved for the GPUs based on if you have just single GPU or 2 GPUs. Here in our case we have currently 2 GPUs connected and 1 GPU integrated inside the CPU, and then you have 4 for connecting directly into CPU your SSD or NVMe SSD drive, and then these like 20 plus 4, it simply means that you are using another 4 to connect CPU with the chipset on motherboard. So then when you want to load model, or you want your model or AI applications to run as fast as possible, then it's usually smart to use only 1 NVMe drive or 2 at the same time. Because if you try to use all of them, obviously they will be sharing the bandwidth. So you have 1 directly connected into CPU, and then another NVMe drives are connected through the chipset of the motherboard, and motherboard is connected only through 4 PCI Express lines of version 4, or in case of Ryzen it's actually PCI Express 5. Then in case of GPUs we have RTX 5090. Please note that even currently, after more than half a year than it was issued into the market, it's still, the AI is catching up, so many applications are not optimized for 5090, and many times you may face some problems when you try to run the AI with 5090, because you have to install the latest torch, which currently I believe is only 9th build, and this simply makes it more difficult, because you try to run it, the GPU simply states I'm supporting this level of CUDA capabilities. I believe in case of 5090 it's version 12, and then many things may fail. So it will be, at least at this point, a little more difficult to fully utilize 5090 because not everything is optimized. But definitely the speed up is noticeable inside 5090 when you use it for AI. And then we have old 4060 Titanium. So 5090 has 32 gigs of VRAM and 4060 Titanium has 16, so we can use it during the multi-GPU setup, so it then helps us a lot to run, for example, some bigger large language models or some bigger models to generate video or pictures. And then we have integrated Radeon inside the Ryzen, which is good when you, for example, capture video or simply want to show something during you are capturing the screen. So then you can use the integrated GPU, and in between your current GPUs can be used for something else. So much about the computer that we use to run it, so that you can assess what is necessary to run this flow, but obviously it will run even on lower specs CPU or computer, but in such case it will take a little more time, even though when AI started and where AI is today is like a huge difference, because now many models are super optimized and can run much faster. Now let's quickly describe all the tools that I use to create ecosystem around N8N, so that before we are able to describe everything, you can start looking into it yourself. So obviously the first thing that we use is N8N by itself. So if you just navigate into N8N and go into the GitHub page of N8N, there is perfect documentation and you can simply run it locally inside Docker desktop. So this brings us into Docker desktop. So Docker desktop, if you just install it, it's probably the easiest way how to run Docker locally. So Docker desktop, N8N, because it was not visible previously due to the zoom in effect. Now we can see it. So Docker desktop N8N. Now, because we want to simply store the data somewhere, then the perfect and free is Baserow, which is something like Google Sheets or Google Tables. You can use it. Then for storing bigger documents inside S3 buckets, the perfect thing to run locally inside Docker is MinIO. Now in case you want to use Postgres, then Supabase is a very nice variation which will install Postgres and many other supporting services. Again, you can run it inside the Docker, so Supabase. Now if you want to manage the Docker, because let's say you have it inside more machines, then you can use Portainer. Portainer is okay. Let's jump into the Portainer on GitHub. So Portainer is like web application that will allow you to control your Docker installations. So if you have several machines where you run Docker and you want to manage it from single place, then Portainer is ideal thing how to do it. And then you can also check that everything is running. Portainer. Now if you want to translate text to speech, then we have several options. So the local option, how to do it, is one of them. And then if you want to use the best what is currently available, then you will probably use ElevenLabs. So if you use ElevenLabs, then you can translate text to speech in a very simple way. It has API. The problem is paid. And now if you want to use something which is not paid, then let's check another option. But in another options, you have really which are in highest quality. You have just 2 or 3. So the first is Higgs Audio. So Higgs Audio is text to speech, which you can run locally, and it should, in case of English, even surpass the ElevenLabs. So yeah, so this is Higgs Audio. So that's one option. But in many cases, what you would need is something that you can run over some API. And for that, there is Kokoro-FastAPI. So Kokoro-FastAPI is using Kokoro text-to-speech. It's pretty good. So in case of English, if you want to use something over API, you can use Kokoro. Now for generating pictures, there is nothing else than ComfyUI. So if you just navigate into ComfyUI and install locally, then you can create many flows inside ComfyUI. and then it's possible to call them remotely inside N8N. So inside ComfyUI you can build practically anything, but originally it was specialized for picture or video generation, and that's for which I'm using the ComfyUI to simply generate pictures in optimized way or generate videos in optimized way. But ComfyUI by itself is just another universe inside which you can enclose yourself, because you can just keep learning and there is still something new. So that's ComfyUI. And let me think if there is anything more. So if we go into Portainer, let's check how it looks like. The Portainer one, if we go into my applications which are running all the containers. Oh yeah, then if you want to search inside the internet for, let's say, AI friendly search, then there is SearxNG. Here, SearxNG, so it's this one. So SearxNG is like a search engine which is AI friendly, so it returns the results inside a JSON. Then Ollama is probably clear if we want to, and it's super popular, so if we want to run models locally, then you can use Ollama as a service for large language models. Then Flowise is very similar to N8N, but N8N has bigger community and growing much faster. And then if you want to index and search, then you can use Meilisearch. And let's also check the other Portainer so that we know what are all the services used. So Supabase, I've already mentioned that. Yes, it seems that I've mentioned everything. So good. So now we can just quickly go over how this story generator works or how is it used. So if I just open video shorts generator, so it's very similar to what you saw with music generator. Here you put the idea about what the story should be. Here you put the tone, I mean, should it be inspirational, educational? This is the same. You select the style, how the pictures should be generated. Then you again mention should it be short or standard. You select picture service. Then you can speed up or slow down the voiceover. Usually 0.9 works the best. Then direct upload, that's again that inside Gemini we can upload directly or indirectly through FlowiseAPI. Here in characters you are telling the AI how the story should be long. Then here you are selecting voice. So these are Kokoro voices and these are ElevenLabs voices. The benefit of Kokoro is that it's running fully locally, but of course it's handling the English, for Czech language. If you want something which sounds like a human, you have to use ElevenLabs. And so far I was not able to find anything else that it's good enough with English that sounds as best as ElevenLabs. Here you can select if you want to upload into YouTube or if you want to merge the SRT files into the video itself. Here we are selecting the text-to-speech provider, so is it Kokoro or ElevenLabs or anything else that you select. And here it's again what is the basic language of the video or the generated story and what would be the translated language which is then used to properly describe the video. Now we just quickly describe how it differs against the music generator, because both the music generator and also the story short generator are using practically the same blocks. So what is possible to share, it's shared, be it upload, be it generating the zoom out using FFmpeg and so on. So the biggest difference in between these two workflows is this first one. So if I just open this sub workflow, what we can see here is that when we execute it, we generate the story, and for story generation we have to use agents, because in case of story, I will just query the Gemini or any other model, you may not get the long enough story or good enough story and so on. So we use agents, and for agents we generate the story premise based on the idea, then we create the characters that would be inside the story. Generating characters is also good from a point of view that you can describe them, and then if you want to keep them consistent, use this description, or for example use models like Flux Def Context to use these generated pictures references. Then we have outline, so this will outline how the story would evolve, because we humans usually like some beginning, some culmination of the story, and then some ending of the story. Then the story writing agent would use all this previous information, write the story with trying to achieve the given length, and then we simply migrate this story into some specific JSON format so that it can be used by reusable blocks. And here we then send it into text-to-speech, and when we have the story as text-to-speech, then we can simply use the similar blocks as for music generator, because then we will just upload the story into the Gemini as a sound, we will transcribe it, but we can also give the story text, then we can split it on story scenes, and then we can continue generating pictures, and from that point on it's very very similar to music generator. And then we just stitch it together and we have a story. But we will be going in more depth in following videos. And for now, this is more than enough. So we've described all the tools which are creating the ecosystem around N8N. They are running locally. The only difference is large language model, because so far even the Ollama ones are simply not powerful enough, or the hardware is not good enough to run them inside personal computer. And then in next videos we will also try to explain how this ecosystem around N8N is created, and then we will be going block by block so that you can ideally mimic what I've created. And with that said, I'm only left with one last thing, and that's to wish you the most amazing rest of the day, and I'm looking forward to meeting with you anytime in the future. And for now, bye bye!